Hey everyone, today we'll be going to do a 3D problem in meeting in one room. So the problem statement here is as follows. But before that, if you are new to the channel, please do consider subscribing the channel and do check out the videos that are already uploaded. Now coming to the problem statement that has been given as in meeting in one room. So here, what is the number of meetings? Three inputs will be given: number of meetings, starting time of each meeting, and the ending time of the each meeting. So we have been given one room, and we have to schedule the meetings such that we are considering like a maximum number of meetings that can be scheduled in that room. So basically what we have to do in this problem statement is, first you can see here it's output 4. Okay, 6 meetings are given, like a 1 2 3 4 5 and 6. Okay, so 4 is the output given, so we'll see how it's coming like that. So first meeting, like the first meeting is like a 0 and 6. Okay, but this is for a certain longer time. The second one is a 1 2, so it will start at 1, it will end at 2. Next meeting will start at 3, end at 4. So counter we can increase as a 1 and 2. Okay, so the next meeting is starting at a 0, so this is less than the end time of this, so we'll not calculate this one. Now moving to this next part is 5 and 7. So 5 and 7, the previous scheduled meeting was 3 to 4. Okay, so 4 after that it will start at 5 and end at 7, so we can consider this. So the counter becomes 3 over here. Next meeting is 8 to 9. So now this also we can consider, since the previous meeting is starting at 5, ending at 7. So this meeting is starting at 8. So we can consider this. Here the counter will become 4. Now moving to the next meeting, starting at 5, ending at 9. Here it's starting at 5, but previous meeting has ended at 9. So it's not possible to schedule these two together. So till now the counter that has been is 4. So the maximum number of meeting that we can schedule is 4. Okay, so the output will become 4. Now coming to the second one, second example that has been given 3 meetings, start time of the meeting and end time of the meetings. It will be like starting at 10, ending at 20. Okay, then starting at 12, ending at 25. Starting at 20, ending at 30. So this is just overlapping. Only one meeting can be conducted at a time, can be held, like 20, 10 it's starting and 20 it's ending, so the next meeting is not possible. And starting at 10, ending at 20, and then scheduling the next at 20 is also not possible. So only one meeting at a time can happen. Okay, now coming to the implementation part of it, we will first see this problem as we'll be keeping the pair. Okay, like starting and ending, it should be together, all these pair, and we'll also keep the index number like a 1 for this first part, second, third, fourth, fifth, sixth, because we have to like count. In this problem it has asked for a total count, but in some problem it asks like give the sequence in which the meetings are getting scheduled. So we will see the both way, so that either of the problem comes, we can modify the same code and we can get the output. So even with this pair of starting and ending, we will also keep like a counter, like it is the first meeting, second meeting, third, fourth, and till this sixth meeting. Okay, so keeping this as a pair, all the three as a pair. So we will just first declare like a class pair. Okay, class pair, and in this I'll keep it as a start. and second one has an end, and third one is the position. Okay, and I'll create a constructor giving it a value as a start, end, and position. Okay, and yeah, input the value. Start is the start. Okay, start, and the second value is the end. Okay, end, and the third value is of position, that will be position. Okay, now after storing this, now we will just use a data structure. We can use that like a list. Okay, to keep all the thing, and we will find like the minimum number of static time, and we will first store this whole of the pair. Okay, like 1 2 3, all the pair will be storing in a data structure list. Okay, so we'll consider a array list of pair. Okay, and we'll name it as a list, and new list. Okay, and then we will be traversing whole of the this start array. Whole of the start array will be traversing, and we'll push all the pair value. We'll call the constructor, put the values, and we'll store it in the list. So for in I is equal to 0, I should be less than start dot length. Start dot length, we don't have to take out the length, it's given. Okay, so we can use the end value over here, and it should be plus. And here just a list dot add, creating a pair, and we'll insert the value. So here we have to insert like a start, end, and then position. So the counter for the array remains same for both the array. For I start and end, it will be same for like a 0 0. Okay, so start of I, end of I, and for the position we'll send I plus 1. Okay, since I is 0, and we'll be counting starting from 1, so I plus 1. Now since I have already inserted into the array list, now what we'll do, like we will pop out the element that has been like a first to start of the meeting. To end, no, not start, because starting array starting meeting with the meeting that is ending first, if we consider that thing, then only we can schedule a maximum number of meeting. So we will be taking out the from this array list, we will be taking out the element that has a minimum value. Like in ascending order, we'll be taking out the value of this end according to end time. Like for the first pair, we'll be taking out first, like which have an ending time of 2, then we'll go for an ending time of 4, then 6, then 7, and then it's 9. Okay, whenever this comes, like both the meeting has the same ending time, then we will be taking the previous one, not this one. Okay, previous one we'll be taking. Okay, like this schedule we'll be following with the popping out of element from this. Since we will be popping out the element, so we need a comparator in Java. So first we will just create a constructor. Okay, we'll create an object for it. Okay, meeting comparator, meeting meeting comparator, meeting comparator meet. Okay, or com, I can say comparator com is equal to new meeting comparator I meeting comparator, new meeting comparator, and then we will be calling the sort function collection collections dot sort, and we will be passing the list value. See, this collections dot sort is usually called to sort this array list, uh, but we are again don't want a normal sorting. Since it is a pair, we will be passing like a sorting condition to it. So we will be passing a object com, okay, and based on the condition given to this com comparator, this array list will be sorted. Now what the condition will be giving over here is like, we'll create a different class, that is a meeting comparator, like what the name we have given over here, the same name should come over here, meeting and comparator, meeting comparator, okay, and it should implements it should implements comparable class. It should implement the comparator, okay, comparator. It should implement the comparator, and the variable is a pair that we are taking, okay, comparator. And yeah, here it will declare a function like a public, okay, public int and compare, okay, public int compare, and we'll pass two object over here. Since it's coming like a two objects from here, okay, so it will be like pair p1 comma, okay, pair p1 comma pair p2, okay. Now here we'll be checking if my p1 if my p1 dot end value, according to end value we will be sorting. Like if my first value, what we are checking over the sorting thing, what we will be checking while sorting is, if my uh, end time, okay, 2 dot end, like two meetings has been given over there, okay, like consider the first meeting and the second meeting. So we will be checking if the end time, uh, which end time, uh, if this whole array is given, so which end time is less, so that should be processed first. So if my p1 dot end is less than the p2 dot end, okay, uh, if this is the condition, then we have to return -1. This -1 means if p1 dot end is less, okay, so no processing is required. We can proceed with normal thing, but else if, okay, else if my the opposite thing is there, like p1 dot end p1 dot end is greater than p2 dot end, okay, p2 dot end, if this is the condition, like the opposite of the upper one, if this is the condition, like p1 dot end is greater than the p1 dot end is greater than the p2 dot end, like here it should be 4 and here it should be 3. So if this is the condition, then we have to just swap the bits, okay, and that we will indicate by returning one value, returning one value, okay. uh, if it's greater, if it's less, then it will satisfy this condition. If it's greater, it will satisfy this condition. Now the condition comes like if it's equal, then what it will do. So we'll give one more condition, if my else if, now if here it comes, then it is equal. So if it's equal, so like here we were saying that both the end values are equal, so we will consider the least value position. We'll see the position. If the position of a p1, like p1, if we'll consider this one, P1 is less than that of P2, then we will return -1. Okay, if P1 dot position is less than the P2 dot position, then we will be returning -1. Okay, and else if means if it comes over here, that means if it's equal, the end time is equal and the P2 position is greater, then we have to reverse the bets. So here we will be returning -1. Okay, so here the comparator meeting dot comparator, that is implementing the comparator pair. Now its implementation is over. So now after this statement, now whenever this list will be sorted in the ascending order of the end time of the meeting. Now after this, what we will be doing is like okay, we will just move traverse throughout the list elements, and we'll check if it's like a meeting is coming in order or not. Okay, so first we'll just start traversing through our array list, and the very first meeting we will be definitely taking it as a 1. Okay, the very first meeting, so it will be definitely taking and its end time will be least, it will be least end time, so we'll be definitely taking the first. So we'll start traversing from 1, not 0. Okay, then n should be, I should be less than the list dot size, or I can say list dot size, whatever the elements are there, is equal to n. So it should it can also be like n, and I should be plus plus. Now if in this question it has only asked about the counter, okay, number of meeting that can be scheduled, but in some problem it can also ask like to tell the sequence of the meeting, how it can be scheduled, like a 1, like in this problem the sequence is like first meeting. Okay, like first meeting we are scheduling, then the second meeting, then the not third, then the fourth meeting will be scheduling, and then the fifth meeting will be scheduling. So 1 2 4 5, the output should it even ask like this output. So we'll also see that case, and we will declare a different array list to keep the sequence in like sequence. Okay, to store the sequence of the meetings. Okay, array list of integer, and we'll call this as an answer, and new array list, and okay, okay, now we'll start traversing from here, and if from here, if we'll check if my list dot get, and we are traversing from the first, so we should already store the first element. Okay, first element point we should store in this answer dot add, and we will be storing like position. Okay, and list dot get 0 dot position. We have 3, list dot get, it's a pair, so it has 3 values, start, end, and pose. So we don't have to do anything with the start and end, we will be having to store the position value. Okay, now here space should not be there. Okay, position value we will be storing over here. So in my array list I am storing the position value, and we will also be keeping like a limit point. Okay, like last meeting ended at second, so this starting of the next meeting should be greater than the limit. Okay, then we will again initialize the limit to the ending of the second meeting, that is 4, and then again we'll be checking if my 4 is greater than the 4 is should be less than the starting of the next meeting. So we will also keep a pointer as a limit that will store the end point of the meeting, that is just we have scheduled. Okay, so list dot get 0 dot end. Okay, it will store the end timing of the meeting. So it will check here if my uh, limit if my limit is less than the starting of the next meeting. So if my limit if my limit is less than the starting of the next meeting, that is list dot get I. Now here the I will become variable. Okay, it will be checking for the first, second, third, fourth meeting. Okay, so I dot n dot start. Okay, starting meeting will be checking. If it is satisfying this condition, then we will schedule it. Now how we will schedule it? First of all, we will add it to the answer array, like a position, like we have done over here. The same thing we will schedule like that way. List dot add and answer dot add list dot get I dot post session, and we will change the limit. Now for the next meeting the limit will be changed. Earlier it was 2, now it will be 4, then 6, and subsequently we will change it. So limit is equal to list dot get I dot end time. Okay, list dot get time and end time. So traversing all the elements, all my sequence will be stored in ANS. Okay, and it will be in the ANS it will be stored like 1 2 4 and 5. Okay, only 4 elements sequence will be stored. Now it is asking for a count number of element. So the number of sequence is equal to the count. Okay, so here we will return a count that will be equal to the number of element that answer is storing. So it is the size. Okay, so we will just check it if it is correct or not. Okay, some error are there. Okay, start 39 number. Okay, 1 equal. Okay, yeah, it got compiled and running it, checking for all the test cases. Yeah, it's running. And now coming to the space complexity and time complexity of this program. Now you can see that we have been using order of n for first uh, putting the elements into the list. So it will be from here it will be like I'll write the whole time complexity. Time complexity is order of n over here. Okay, order of n over here plus. Okay, why I'm doing this plus over here? It's like we are also sorting the whole list. Okay, so even that require order of n log n. Okay, so sorting, for sorting it will be like order of n log n. Okay, n log n times n log n times, and then we are just moving to one more traversal over here, like for getting the each element and storing the sequence in the answer. So one more traversal will be there, like a order of n. Okay, so we'll be taking the maximum out of it, so it will be order of n. And since it is low, so we'll ignore this one and we'll take the maximum out of it. So the time complexity of the whole program will become order of n log n, and space complexity we are using an array list. Okay, we are using an array list of n size. Okay, so it will be like a space complexity will can be we can say it as order of n. Okay, order of n space complexity. Okay, so this was the program that is done through a greedy approach, and it's a easy based program in meeting in one room. You can practice it on GFG, and if you have any doubt, just put it in the comment section. I hope to see you in my next video. Till then, thank you.